was here, I was explaining this one and map type. Map type was this one. Okay, so I was talking about this. Now, I was saying that there are different tests, okay, for finding whether a series converges or diverges. I don't want you to know this test, these formulas by heart. We are going to have an open book exam again, but you have to understand them. Okay, this is important. You have to understand them, and in real life situations, you are not going to memorize everything. It's really hard. We have computers, we have recording stuff. They can do that memorizing thing for us, and we have internet. We can search, but the ways are important, and knowing how can use them. So in your future life, when you are in job, when you are working in engineering, you will have all the formulas. But if you don't know how to apply them, how to use them, then that's a problem. So that's what is my aim, is teaching you what are they and how you can use them, and making you familiar with different types of series. Okay, here series are numbers that or functions as a result of some functions. When we add them, we have a plus sign in between. Okay, sequences again have comma. Sequences have comma, don't have a plus sign. Series have a plus sign in between. These series are the summation. Okay, whenever you see a summation and some expression in terms of n, it's a series. Okay, whenever you see a summation, it's a series. And I said that there is no convergence. It's not possible to use convergence test for n-term test for this type of series. But this series, ARN, the series in front of ARN, what were they? I was explaining what kind of series can be written in ARN. Okay, so this type of series from 0 to infinity, ARN, what this means. Now here, be careful, I didn't write these brackets. When I write brackets, it means derivative. Okay, so from now on, be familiar with these expressions. When I write brackets, it means derivative, and when I don't write brackets, it means power. Okay, here when n equals to 1, the first, but here in fact this series starts from 0. You see that the starting point is 0. I use the nth term, but we also have 0 when n equals to 0 here. Okay, so what is this here? A r to the power 0. So a r to the power 0, let us look what it is. 0, okay, equals to a, okay. Yes, so we can also write it like this. Just a moment. We can also write it like this. This is when I have this 0, but it's not necessary, just yes, 0. This equals to this one. Okay, yeah, because we know the term, it is 0 here. So so this is a r to the 0. It's the 0 term is a. So this series, in fact, from 0 we have to have this also plus a, because it starts from 0, not from 1. It starts from 0. A plus a to the power sorry, a plus ar1 plus ar2 plus ar3. Okay, this is a geometric series, and we were talking about how we can find whether such a series converges or diverges. Okay, so this is our formula for it. Let me have it as a presentation. There's my okay. Just a moment. I was here. Okay. I'm trying to find my laser, but I couldn't find it. I'm continuing like that. Okay. So here, this condition of convergence. Okay. So this, we say that this geometric series converges. Okay. When these are absolute value of R. So this means that it's not minus. Okay. So when absolute value of R, for example, 2/3, okay, it is smaller than 1. When it is 2/3, when it is 1/2, when it is 2/6, okay. So the absolute value, when the absolute value is smaller than 1, then we say that its sum diverges to this number. Okay, so let us have an example about this. Yes, here okay. So for this one, let us have an example, and let us have a geometric series, okay, a series in this form, and where R is 2/3. Wait, R is 2/3. 2/3 to the power n. I have to have this bracket. Yes. So this is a geometric series. Okay. So here we say that it converges. Okay. And the limit is equal to. We say that this converges and its sum, the limit is equal to A over, look at the formula here, it's a little bit small. Okay, the formula is here, okay? When we have this R smaller than 1, the absolute value of R, it means that this can be minus 1/3. It's not important, okay? So we take its absolute value 1/3 is smaller than 1. When it is smaller than 1, then we say that it converges, and when we do this addition, you know that this is a summation. When we do this summation, the result is A over 1 minus R. Okay? So here the result would be according to this. Yes. So A over 1 minus R. 1 minus R. R is 2/3 here. Okay? So 2/3. I have to write 2/3. 2/3. Okay. So here the result would be A over 1/3. A over 1/3. This is 1/3. Okay, and the result will be 3A. Okay, if you multiply it here, it will be 3/1. So it will be 3A. So this series will have result as 3A. Why? Because we solve it as a limit equation. Okay, so you know that whenever we have an series where we have infinite summation, then always we can convert it as limit, as here we have n approaches the infinity, then we find that it is 3A. So here, if it is for this geometric series, it converges to 3a, it is convergent, and the result of this summation is 3a. So you have to know this formula, okay? But as I say, it will be an open book, but you have to know where and how you are going to use it. You have to practice it, okay? So this is a over 1 minus r. For r, when r is smaller than 1, when absolute value of r is smaller than 1. So what happens when r is bigger than 1? For example, if we have a series like this, if we have a series like this, okay, just a moment. If we have series like that, where this is 5, you know that here 5 is bigger than 1, therefore we say, without doing any summation, we say that this series diverges. Okay. Without doing any summation, we say that this series diverges. This geometric series converges, okay, and the result is 3a, because here this is smaller than 1, this r, absolute value of r smaller than 1, here it diverges because it is bigger than 1.